See, I don't know if I could cut it in one of those places. I don't know. I mean, I assume there wasn't a bar in the lobby. No bar in the, was there a lobby? No lobby. Yeah, that's... I don't need light. But well, I'm gonna need TV. I'm gonna need internet. There should probably be I don't need a bar like right there. I'm not like an alcoholic, but I mean, there should be one reasonable walking distance. You know, I don't know, kind of like Highland House distance, right? Yeah. You know, dry campus, but active bar right across the street. It is kind of funny how Concordia has a pretty close relationship with Highland House. I think we get a 20% discount there. I assume students do too. I'm pretty sure. Yeah, not at the bar though. I don't think you get. Yeah. Oh, so never a sip. You couldn't even maintain a straight face.
Wine and communion on Sunday.
Well, that's it. You bring your own communion the rest of the time. All right. Let's see where we left off. So we were in the middle of mimicking what we were doing in Alice. Let me bring Alice back up, and I think we're just about done making that connection, and then we'll start looking at Java stuff in general. So while that's loading, let's rehash what's going on over here. So we have our basic Java program here where we create, so think of this like our scene, if you will. And well, we actually started creating another scene here, but we'll come to that here in a second. Well, let's just look here. So we have our scene. Inside of our scene, we have 9 Monkey Kings. We have 1 Mad Hatter. And these guys are represented by our objects. So we have our Monkey King object and our Mad Hatter object. So our Monkey King object, we've just put in there the specialty stuff that belongs to Monkey Kings. And notice that a Monkey King is a biped. And we started talking about inheritance. So last time, probably have a picture up here. There we go. So we have an object. From our object, we have 2 objects, a biped and a scene. And off of biped, we have Monkey Kings and Mad Hatter. So both of these guys get everything that's in a biped, and both of those guys, or bipeds, get everything that comes from a generic object, so does scene. Well, by the way, I think I posted it on Slack, but with inflation, I think I put a number for what the actual...
1,600?
Yeah, like crazy dollars for that memory, yeah. So that was that Y2K thing we talked about and the cost of memory. Okay, so here's our Monkey King and our Mad Hatter, and let me just make sure that there wasn't something else that we were supposed to talk about before we jumped into this. So we talked about the various primitive data types that exist in C, and we'll look at those more closely when we get into Java. Right now we're kind of looking at Java at the very high level, like what are the equivalents in Java to Alice, and then we'll look at Java more specifically, building variables, solving problems. So kind of going back to the Alice things we were doing, but in Java rather than kind of a relatively complex model of Alice like we're building right now. We talked about ASCII versus Unicode for that character. So chars are unsigned 16-bit numbers. So in C and C++, these were actually 8-bit, unsigned 8-bit numbers because they only held 256 unique characters for the ASCII character set. Whereas in Java and newer languages, they use the Unicode character set with other symbols in it other than just English American symbols. So we have 65,536 unique characters in Unicode, the first 256 of which are the ASCII character set, so they match. All right, so that was the point of why a char is unsigned while all these other guys are signed. So bytes, shorts, ints, longs all can hold negative and positive numbers. Chars, we think of them as holding characters, but in actuality they hold numbers, but only positive ones. All right. So that means we get the full set of bits to represent the number in a char, where in a byte we only get 7 of the 8 bits for the number, because one of those bits is there for the sign. Okay. So ASCII versus Unicode. Then we talked about the Y2K bug in terms of cost of stuff. Here's the 8-bit number thing with the 2's complement. Okay, so I think that we were good with that stuff. All right, so coming back here to our scene. So in our scene, we look at our scene over here in Alice. Just visually, we have 9 Monkey Kings and 1 Mad Hatter, right? These are the objects, the players, that you will, that are in our scene. And we've represented that over here in Java. Here's our 9 Monkey Kings. And since we're doing all this text-based in Java, we don't really have that spatial awareness where one Monkey King is to the right of the next Monkey King. We just have these guys are all just kind of laying on the battlefield, if you will. They're in the scene. So we have 9 Monkey Kings. We have 1 Mad Hatter. All right. And then to mimic Alice, we look at our code, we have our initialize scene, which calls my first method. So this is what initialized the event listener for when the scene was activated. So here's my first method, and what does the my first method do? It throws the Monkey Kings into an array. It goes through and it sets their original paint equal to their default paint. So let's look at a Monkey King. Their original paint, we just decided it was a string called normal, which we can say represents a color, the normal Monkey King color. All right, and so back here to our scene. So we go through and we set the original paint to a Monkey King's default paint. That's what we're doing there. Same thing as we did over in Alice. Then we create a local variable. So this is a variable that lives and dies with the my first method. So its scope is only inside of my first method. This maps over here in Alice. So let's look at my first method here. So here's us going through. Here's our loop for setting the original paint for all of our Monkey Kings. Here's a local variable called keep playing that we started as true. So this is something that lives as part of the my first method, not as something global that's owned by the scene or owned by our Mad Hatters, our Monkey Kings. All right, and then we call the play tic-tac-toe function. So this is where our Mad Hatter was asking guys to do some stuff. So Mad Hatter says play tic-tac-toe, and then he's going to start getting some information in from the user. So when he, so as long as he's supposed to keep playing, he's going to call play tic-tac-toe, which is a function of the scene. So let's get to our scene. Here's play tic-tac-toe. Play tic-tac-toe takes no parameters, does all of this stuff. So here's our play tic-tac-toe function. Fills up our array of Monkey Kings with our 9 Monkey Kings. Sets a local variable pause equal to 0. This is an example of how Java is a strongly typed language. So pause is a variable here named pause, and it's of type int. So we're only allowed to put integers in there. Just like in, well, here's user input, player mover, whatever. Just like user input here, oh, here's pause. Just like pause here is a whole number capable of holding, well, currently holding at 0. So Alice is also a strongly typed language. All right, Mad Hatter then says, let's set up the board. So it's just him printing something to the screen. So he's going to go ahead and shrink our Monkey Kings. So he's going to tell each Monkey King to shrink themselves. And what does shrink do? It just goes through for a specific Monkey King and sets his variable is shrunk to true and who moved me to -1. So this is changing some attributes associated with our Monkey Kings. These guys here, Monkey Kings, know about who moved me. They also know about whether or not they're shrunk. They also remember their original paint, and then they have a procedure for updating their paint to their original paint. All right, so we'll go back in here. So play tic-tac-toe is going to say, let me set up the board. It's going to shrink all of the monkey kings. It's going to initialize some variables for our user input. And then while there's not a winner, we're going to do some stuff. So this is where we left off. Going back into Alice, this is the loop here that says while there is not a winner, we need to go ahead and read something in from the user. So it is bipeds that know how to get information from the user, except I think we wrote it inside the Mad Hatter. So we tell the Mad Hatter to get an integer from the user. And let's see if we wrote that. Yeah, here we go. Oh yeah, start here. So Mad Hatter, get input from the user. So we create a scanner. This is a Java tool for reading stuff in from our user for right now. It can actually read stuff from files and things like that as well. But this will read in from a user. We're going to output our message. We're going to read in our answer, and we just prove that we got the answer by printing it back out to the screen. So this is kind of where we left off. So inside of scene, while is winner is equal to false, that's right, right here. While there's not a winner, we need to go ahead and grab the user input from our Mad Hatter. So Mad Hatter should have a function called getInteger from user, given a message, and it should spit out that integer. So let's go into our Mad Hatter. So instead of getInput, let's call this getInteger. And this guy should no longer return a void, it should return an int. And we'll go ahead and grab the next int from our scanner and then ultimately return that. All right, and it's saying that this could possibly, oh, we need to have this be an int. All right, so get integer from user takes in a message that we should display. This is where the Mad Hatter displays the message to the screen. Then we read in the answer, and then we return that answer. So coming back here to our scene for is winner, or while is winner is equal to false, or while there's not a winner, the very first thing we should do is get our user input from the Mad Hatter. And the question we're asking is, please enter a move. So we're going to say user input is equal to this dot Mad Hatter dot get integer from user. What was it? Please enter a move. Okay, something like that. So now we have our user input. Next is we need to check move success. So this is try to make a move, so on and so forth. All right, so are we starting to see how all these different objects are working together and things like that? And hopefully we also see that under the hood here in Alice, there's a whole lot of stuff that is actually happening. In your opinion, which looks more complex, Alice or Java? Which would you rather write this in if you knew both? I don't know if there's a real right answer to this. You say Java? Why? So the very aspect of Alice that is supposed to make life easier actually makes life harder once you get good at it.
Yeah, I feel like efficiency-wise, like if you know what you're doing, Java's gonna be faster.
All right. So Alice is, and this is kind of why we transitioned to Java right after midterm, is for the first 8 weeks we're kind of learning programming logic and things like that. But we also have this weakness of our once we get decent at that, now we have to fight with Alice as a tool. The drop downs, getting things to line up, all that kind of stuff. Well, Java adds a lot more complexity into it because we have to now start remembering syntax, and we've introduced typos into the situation and that kind of stuff, but we do have more flexibility. Now, the good news for us, and this is part of why we also use a tool like Alice earlier on, is we probably would not start with a problem this complex in Java, at least not in terms of the number of objects. So when we talked about the difference between procedural programming and object-oriented programming, we used the telephone example. Okay, we talked about a telephone. The procedural telephone shows all those wires, detail the public and the private details, where the object-oriented language looks like a telephone. We know the details are there, but it actually looks like a telephone. So from a power tool perspective, an object-oriented language we can say is more powerful. But it also now almost forces us to solve this problem differently. All right. Typically, when we're first starting to learn a language like Java, or even a loosely typed language like Python, which we're actually going to look at as well, just to see the difference. Because again, this goes back to what we talked about first week of class. That programming is programming. It's computer programming is a skill set. The language doesn't matter, right? So, it doesn't matter whether we're working in Alice or Python or Java or Objective-C or Swift. They're all the same, okay, minus the drop-downs, okay, which is still the same. It just becomes frustrating, right? But if we were to write tic-tac-toe in, let's call beginning Java, we would probably write it as a procedural tic-tac-toe game, as opposed to an object-oriented tic-tac-toe game, which almost makes us take a step backwards, right? We're seeing here, as we're trying to mimic Alice, that this project's becoming large. Alice is doing a lot of work for us in the background. There's a lot, and keep in mind, we're not even completely mimicking it. This is graphic-free, what we're looking at right now. This is going to be a completely text-based tic-tac-toe game. So we can imagine we're maybe almost halfway done probably. Now it's just a matter of duplicating all these different functions, and we're seeing, we've kind of gone through the exercise that we can literally walk our functions line by line by line and pretty much identically copy them. Just convert from Alice syntax to Java syntax, and life should go on. This is not the way we would likely write tic-tac-toe day one as a beginning Java developer, because we probably would not leverage objects yet. And realistically, to play the game of tic-tac-toe, we just need the idea of a first player and an idea of a second player. We don't actually need a Mad Hatter to sit there and govern the game and a bunch of Monkey Kings to shrink and stuff. We solve that problem kind of like the Matrix, right? We solve the problem in terms of the rules that were afforded to us by Alice. Okay. Java is going to be far more boring in terms of those rules because we don't automatically get the ability to do this stuff in a swamp, and we don't get to pick all these different characters that look cool on the screen and stuff like that. But we then get the benefit of having spend more time on the logic rather than on the graphic side of things and making things move a certain way. So having said that, what I want to do is I want to actually pause this version of tic-tac-toe, and we're going to just say for the time being that if we were to continue following the line, we would eventually mimic our Alice tic-tac-toe. We would just copy function for function for function and accomplish the same thing. But we've noticed here that we've built bipeds, and we've built Mad Hatters, and we've built Monkey Kings, and we've created instances of these guys, and we've kind of seen how all these guys work together, right? All right, so now let's go ahead and let's write tic-tac-toe as a normal Java program that a beginning Java developer might write. All right, and then we're going to look at we'll probably look at the same thing in a language like Python as well, just to see an example. All right, so let's come in here and let's just do it. Let's do it inside of driver. We won't even change the project. We'll just choose not to use any of those objects. Okay, so we have those objects laying out there, our Monkey Kings, our Mad Hatters, but they're sitting on the sideline. We're not bringing them into our project right now. So we're going to do everything from our main program here. All right, so right off the bat, let's think about to play tic-tac-toe, we need to be able to display a board, right? So we had to come up with a way to represent our board in Alice. We did that with a grid of monkey kings. Well, in Java, we could effectively draw a board out of like, dashes and, and stuff like that. All right, so let's go ahead and let's just say public. Well, actually, we don't need to say public. Let's just say static void display board. And we're just going to make a static board for a second. All right, so remember way back to the beginning of the course, we talked about the way human beings solve problems. Memory, asking questions, repetition. And I mentioned that 100% of programming languages have facilities for those three things, right? So if you were learning a new language, if you can learn how to do those three things in that new language, once you've gained computer programming as a skill set, you can already solve a large classification of problems. All right? So before we can display a board, we need to understand how we define variables, how do we ask questions, how do we write loops. We've already done them in the context of copying our Alice over, but let's give ourselves kind of a cheat sheet. All right? So right up top here, we're going to define a couple of variables. So we're going to say memory, this leads to variables. All right, so it's the generic syntax is type, name equals value, semicolon. All right, so that's the way we define variables. So as an example, int a is equal to 5. So that's our Alice whole number. We can say string s is equal to hello. This is our Alice text string. And then, let's see, so we've dealt with whole numbers, we've dealt with text strings, we had booleans in Alice, right? So we'll say boolean b is equal to false. This is our Alice boolean. And then we had arrays of these various types. So an array is a collection. So an array in Java, so let's do Java arrays. Syntax is type, open close square bracket, name equals new, type, open number. So this is, well, why don't we just say how many? So for instance, int array AR is equal to a new int array 10, gives me an array capable of holding 10 things. So this is empty array that I can add 10 things to. Now that's something we have not been able to benefit from in Alice. Alice requires us to build the array in its entirety to begin with, and then it allows us to easily manipulate that collection. It doesn't allow us, or at least we didn't talk about it. It seems like it should, but we couldn't come up with a good way of doing it. It doesn't allow us to create an empty array and then add crap to it as we needed to. All right, didn't give us that ability. So in Java, we can create an empty array with 10 empty buckets capable of throwing stuff in there, but we haven't actually put stuff in there yet. We can then say something like AR at bucket 0 is equal to 5. AR at bucket 1 is equal to 6. Adding things to that array. Okay? Similarly, we can say int array AR2 is equal to 1, 2, 7, 14, something like that. So that's pre-creating the array with those 4 things in it, 1, 2, 7, 14. But that's not read-only. We can change it. I can, on the very next line, say AR2 at bucket 1 is equal to a negative 5. And that will change this 2 to a negative 5. Make sense? So these are arrays, still variable types in Java, but these are our collection. So this is Alice, well, let's just call it collections. Okay, so here's standalone single variables, single name with a single value. Here's standalone arrays, single name with a collection of like values, with the upgrade in Java that we can now create an empty one and add stuff to it, as opposed to having to create our entirety at the very beginning. All right. So that's variables, that's arrays. So we've covered the memory side of Alice, right? At this point, we're pretty limited on the kinds of values we're allowed to store. We know how to store whole numbers, integers in Java. We know how to store text strings, strings with a capital S in Java, and we know how to store Booleans. We've also kind of seen that we can have monkey kings and we can have object types, but we're kind of taking a step backwards, because usually when we look at a general purpose syntax-based language like Java, we start off by pretending like objects don't exist. So we actually teach the object-oriented language as if it's a procedural language, and then we add the object back in. We now have the advantage of understanding conceptually what objects are and how they might work, making that connection to how we solve problems as real people. Okay, but now as we've kind of gone through the exercise of mapping that over to Java, we realize that that actually starts becoming kind of a large project, right? Something we're certainly going to be able to do, but something we don't start with because we want to get practice with the Java way of doing things. All right, so this is our Java variables right here. Now, let's do conditionals. So asking questions. Conditionals, generic syntax is the word if, open parenthesis, Boolean expression, closing parenthesis, opening curly brace, list of, well, let's just say one or more statements, closing curly brace. Optionally, we can have an else, opening curly brace, one or more statements, closing curly brace. Okay, that's an if. So for example, we can say if A is less than 10, else, let's just do A is equal to A times 2 or something like that. So we're asking a question. If this is true, do this. However many things are in here right now. I have one statement, but here I can say, actually let's do that. We'll divide it by 2 here. We'll multiply it by 2 there, so it gets bigger if it's less than 10. It gets smaller if it's greater than 10 for no good reason. So in this case, if this is true, I'm doing 2 things. If this is false, I'm doing 1 thing. The else is optional. We do not have to have an else as part of an if. We can ask a question and only do something if it's true. Optionally, we could do something in the event that it's false. Okay? So this is equivalent to our Alice if statement. So that's asking questions. No real difference from Alice, except instead of using the drop down and the drag and drop stuff, we have to write this syntax. So some challenges we have to deal with in Java is remembering that for every opening curly brace, we have a corresponding closing curly brace. So something I typically do to minimize the number of errors you end up with is when I put an opening curly brace, I immediately press enter and put the closing curly brace. A tool like Eclipse does that for you. All right, so it helps you to not forget, but it's a good programming practice is to always kind of get the 2 pieces of bread out and then build your sandwich in the middle. Okay, rather than 1 piece of bread, build your sandwich, and having to go back to the fridge to get the other piece, but you might get hungry and just eat it without the other piece of bread. In Guatemalan prison. It's the thing. It's a true struggle. All right. All right, so that's our conditionals. Loops, so repetition. So we have a for loop. Syntax for a for loop is for, opening parenthesis, initial counter, semicolon, Boolean expression, semicolon, change counter. opening curly brace, one or more statements, closing curly brace. We also have a, let's just look at our loops right next to each other. We also have a while loop, while Boolean expression, opening curly brace, one or more statements, closing curly brace. So as long as this is true, keep doing this. Kind of like while there's not a winner, keep doing something. So two different style loops. This is a counting type loop, so this goes through all the numbers between counter and whatever our Boolean expression dictates we should stop. We'll look at an example here in a second. We also have a do while loop, so do one or more statements while Boolean expression, semicolon. So this is what's called a, let's say this is a post check loop. That is, we check the Boolean expression after we execute the body of the loop at least one time. For loops and while loops are both pre-check loops, where we ask this Boolean expression before we ever execute the body of the loop. Make sense? So a couple of different, these loops, they all repeat stuff, but they have a couple of caveats associated with them that helps us pick the right loop for a specific problem that we're trying to solve. All right, so let's just look at a couple of examples of for loops and while loops. We'll look at the counting to 10 problem. Just that's a good starting thing to do. So we'll say for int I is equal to 0, I is less than 10, so let's go 0 to 9. I is equal to I plus 1. And we'll say system.out.println I, like that. So this starts I off at 0, so this creates a new variable named I, whose scope lives and dies with this for loop. So this is kind of a convenience of for loops in languages like C, C++, and Java and C#. The same syntax works for all of those because it came from C. That is, this is kind of just a counting variable, right? For the big picture, it's a throwaway variable. So we can just define the variable right here as part of the for loop. And as soon as this for loop's done, this variable I is no more. So we can then reuse a counting variable I 10 lines later and use it again because it's mostly a waste of time. All right, so this allows us to keep it kind of compartmentalized. This will print out all the numbers between 0 and 9. As opposed to this, if I'm looking at a while loop example, so int I is equal to 0, while I is less than 10, do system.out.println I. We should already have a closing curly brace on there. And then we'll say I is equal to I plus 1. So in this while loop, both of these are pre-check loops. These are both pre-check loops. They both have the exact same output. There's a little caveat difference between these though. In our while loop, this I is being defined outside of the while loop. The while loop does not come with its own variable scope. For loops do. All right, kind of a special thing about for loops. So this variable I right here has a scope that's local to this main method. So it belongs to the main method. So that means from this point forward in our program, from line 42 all the way to the end of main, I is already a variable. So I cannot now have another for loop. I can't do this a second time because it's going to yell and say I is already taken. It's already in this scope. All right, it's not going to be happy about that. So that is a little difference between that, where if I take this while loop out, just for a moment, notice it's cool with the I. I have two for loops back to back, both counting on the same variable, but even though the variable looks the same, it's a different version of I, because I was local to the environment that came with that for loop. Make sense? All right, finally, a do while loop. I'm just going to go ahead, and since we already have I, I'm just going to reuse the I. So I'll say I is, well, let me quickly show you one thing here. This is an error. This is not. So we notice that system.println I is an error because I was local to the for loop here. It died when that for loop ended. Therefore, we no longer have a variable named I once that loop is over. Evidence that that I is local to the for loop. As opposed to our while loop, it's perfectly cool with this I right here because I is a variable that exists in this entire variable scope from this point forward. It didn't just live and die with the while loop. Make sense? So one's not necessarily better or worse than the other. Each one kind of has a purpose, right? If you need to use that counting variable later on, you can with using a while loop. Or in a for loop, you can always do this. You can say int I is equal to whatever, and then you can just redefine it in here. And let me show you why I gave it an initial value. Okay, so there's I right there. Start I equal to 0. It's now cool with this because I's scope actually began before the for loop. The for loop gave it an initial value of 0, but it still is alive after that for loop's done. Make sense? So if you did need to give yourself that value after the fact, and a for loop was the loop that you chose to work with, because for loops are kind of one nice thing about a for loop, it lends itself to counting type problems, but it's also kind of self-contained. You get everything squeezed into one package there. Here's your starting value, your Boolean expression, and your change in value. Where with a while loop, starting value kind of comes beforehand. Here's your Boolean expression. We change the value at the end. You have the pieces spread apart. Logically, they do the same thing. If you wanted to just spend your entire programming life always writing for loops or always writing while loops, you could do that. All right. Typically speaking, and let's switch this back just so we don't have errors all over the place here. Generally speaking, for loops are for counting problems. While loops are for problems where we do not know how many times we must repeat. So, for instance, keep continuing until a key has been pressed. Keep playing tic-tac-toe while there's not a winner. How many moves is it going to take to have a winner? Could be 3. It could be 6, I guess. 5. Or it might be a lot more than that. Okay? So we don't know how long we're going to have to spin for. So a while loop lends itself to that kind of problem. The last guy, our do while loop, we'll go ahead and repurpose our I here. So we'll just say I is back to 0. Notice I did not define it again. I just gave it a new value. It's already defined. It's already in scope. So right here, I gave it a new value. Common mistake that beginning programmers make. They constantly want to redefine variables. If you already have a variable defined and you want to just use it for a new value and you're done using it for its old value, you don't want to overwrite an old value if you're still going to need it, right? So then you can go ahead and just repurpose it. So I'll start I off at 0. We'll go ahead and say do. I'll steal this guy right here. We'll print out I. I will become I plus 1. And we're going to keep doing this as long as I is less than 10. So there's a do loop. Okay, and this guy lends itself to problems where the body must execute at least once. Okay, and what I really mean by that is let's look at the while loop versus the do while loop. As we mentioned above, do while loops are post check loops. We execute the body of the loop one time, then we check the Boolean expression. While loops are pre-check loops. We check the Boolean expression first before we ever execute the body of the loop. All right, so having said that, if in my while loop I start I off at 10, the output of this while loop will be nothing. Actually, it'll print out the 10 right there. But let's dump that for right now, since that's not really part of this example. All right. So if I start I off at 10 and then I ask, is 10 less than 10? It's not. We fall past the while loop, never printing out anything. We never get into the body of that while loop. As opposed to here with the do while loop, if I start this off at 10, it'll print out 10. 10 then becomes 11. Then we ask the question, is 11 less than 10? It's not. Now we're done. So these guys in the current setup have different outputs. The first one prints nothing because it's a pre-check loop. The second one prints out the initial 10 because we do the body one time before we get to the Boolean expression. Make some sense? So do while loops lend themselves to problems with that we have to do something at least once. The most common example of that is authentication. You must give me your username and password one time. I'll try to log you in. If you screwed up, then I'll ask you again. Okay? All right, so those are our 3 loops in Java. Questions about that? Finally, we see for the other repetition, we talked about functions. So here's a, let's call this a Java function, int param1, char param2, something like that. We can then say system.out.println param1 concatenated with a hyphen concatenated with param2, something like that. So syntax for a Java function for right now, just pretend like the static keyword is required. We'll move away from that later. But it's the return type. So let's go ahead and give this. This is return type. That's the kind of value it's going to return. Followed by name, followed by opening parenthesis, followed by comma, delim parameters. Well, let's just call it inputs. That's what these guys are. Closing, opening curly brace, one or more statements. Closing curly brace. That's the syntax for a function or procedure in Java, because in a procedure, the return type would just be void, because procedures do not return a value, functions do. Make some sense? All right, so from a programming as a skill set perspective, okay, programming as a skill set perspective, right here is the entire Java programming language. Obviously, there's a lot more to it than that in terms of bells and whistles and extra things built into the language. But strictly from a programming as a skill set perspective, that's everything you need to know to use memory, to ask questions, and to do repetition in the Java programming language. And now we already have a beginner plus intermediate minus programming as a skill set, problem solving skill set now from the first 8 weeks, right? You know, we feel like the syntaxes may be a little rough. You know, no matter whether we're dealing with Alice or whether we're dealing with Java, if I told you to solve a problem, it's going to be just as difficult to sit down and do it in Alice as it is in Java, because you haven't gotten that skill, you haven't gotten the reps in yet for solving a problem from inception to the actual algorithm. If we have the algorithm, we can then plug it into Alice or plug it into Java fairly easy. It's that first part that we struggle with. That's the programming as a skill set. But we're better at it today than we were 8 weeks ago. That should be the punchline, right? We might still suck, but we're better today than we were 8 weeks ago. Java is just our extension of, instead of using Alice, we're now using this syntax to do it. And now we've learned all of the things we already knew how to do in Alice. We now know how to do it in Java. All right. So for next class, I'm going to take all this. Let's just take it like this for right now. I'll copy all of this. And I'm going to go on to Slack. I'm going to add a snippet. I think it'll let me choose Java, but Groovy is the same thing. There we go. Here is the Java primer for programming as a skill set. So we'll upload that there. So next class, we're going to have a quiz dealing with the stuff on there. You will not have to solve any problems. I might ask you to define a variable named hello and set it equal to your first name, for instance. I won't ask you to write an algorithm to do anything. I might say, create a function named XYZ that returns a string and takes 2 integers as parameters. Create the function kind of header for that. Make sense? So you should be able to say string XYZ, open parenthesis, int A, int B, opening, closing curly braces. Something like that. So study the programming as a skill set primer for Java and be prepared to have a short quiz at the beginning of class next time on that stuff. No problem solving, just proof that you've learned the logic, or learned the syntax rather. Questions, comments, concerns, bribes? All right, I'll see everybody on Friday. We have class Friday, right?
Yeah.
Seems like we only have class every other week these days.